Hi, everybody. Welcome back to my channel, Numbers with Nora. This is a math tutoring channel that will help you out with all your math needs, questions, and homework and what so. This particular video is going to be on Algebra 2, Chapter 1, Section 1.1, Parent Functions and Transformations. I'm following a free book called Big Ideas Math, Algebra 2. I'll put the link with this video as well. It's a free PDF and it has lots of flashcards and practice problems. So you can follow along with me in that book. But if you have another Algebra 2 book, you should be able to follow along just as easy. So let's start. The objective of this lesson is to describe transformations of parent functions. And so as always with math, let's start with our math vocab so we understand what we're doing. So a parent function is just basically a basic function in a family of a function. Okay, and we'll get to see examples of those in a second. A transformation is going to be something that changes the size, shape, position, or orientation of a graph. Right? A translation is going to be something that shifts. Oops, let me take that out. Shifts a graph horizontally and or vertically. Okay. And then we have our reflection. Our reflection is when our graph, or it's going to be a flip over the X or Y axis, and we're going to see what causes that in a few. And then our vertical stretch is when we have a factor that is greater than 1. Function that is greater than 1. An example of that, we'll see like something annotated as a more than 1. And then we have a vertical shrink, and this is when a factor of my function is greater than 0 and less than 1. An example of that is just 0, less than a, less than 1. Okay. So that's our vocab that we'll be using for this section. And let's get into some examples. Or actually, before the examples, let's get into our course on our concepts. So like I said, we're going to be dealing with parent functions. The parent function is just the function that usually goes through the X and Y axis, or your origin. And it's just the most basic part of that function. So for this one, we can see we have our linear function right here, and as well, it's just y equals x. It goes through our origin, has a slope of 1. Okay, this is our absolute value function, y equals absolute value of x. Again, our vertex is on our origin, and we have a slope of 1, which means there's nothing being multiplied by my grouping symbols right here. And then our quadratic y, or f of x equals x squared. This is going to form a parabola. And right here, our parabola has a vertex at 0, 0, or our origin. Okay, those are all of our parent functions. And this one is just a constant. All right. And down here, you can see all the domain and ranges. And we'll sit there and go over domain and ranges of certain functions probably later on. Not so much right now in this chapter. So let's go ahead and see a prime example. We'll sit there and do example 1 first. So this one says identify a function family. Identify the function family to which f belongs. Compare the graph of f to the graph of its parent function. So right here, they gave us a graph, but let's go ahead and graph our parent function. This one is going to be an absolute value function. So the parent function for absolute value function is always going to be y, or you can do f of x, either or. Absolute value of x. And the graph of that parent function, that means our vertex starts at our origin. And we have a slope of 1, so I go up 1 over 1. That's rise and run. Up 1 over 1. Up 1 over 1. And that's going to give me my vertex. And I would do the same thing going this way. Up and over 1. Oops, that little thing's in the way, so I can't really get it perfect. All right, so our parent function will look somewhat like this for our absolute value function. Of course, we have the arrows indicating we're going on and on. So we want to sit there and see how our graph changed, our blue graph changed from our parent function, the black graph. As you see, the blue graph went up 1, right? So this is going to be a vertical shift up 1. All right, and then it also has another transformation because in comparison to our black graph, our parent function, our blue graph sits there and looks skinnier. So this is going to be called a vertical stretch, right? So you think of like we're taking our parent function and we're pulling it by the arrows and stretching it up. So it's going to get skinnier, okay? And we'll go more into these transformations in a few. All right. So now let's look at example 2. Graphing and describing translations. Graphing g of x equals x minus 4 and its parent function. Then describe the transformation. So this one, our parent function for this is just going to be a line. That's just y equals. Usually we see it as mx plus b, but this one's just going to be y equals x. And just notice you could write it as y equals mx plus b, where m is my slope and b is my y-intercept. You can think about it as that as well. Right. And it's just like this one just doesn't have a b or an m. Well, my slope is 1 here, but there's no, the y-intercept here is 0. So when I sit there and look at this, how it's different from my parent function, y equals x, I sit there and circle all the differences that it has. So I have it being subtracted by this 4. So that's one transformation right there. And whenever that transformation is not involved in my grouping symbols, I like to think that we're dealing with our vertical transformations. That means up and down. So this is going to be a line. Remember, if I graph my parent function, my y-intercept for my parent function is 0, 0. So it's at the origin. Oops, sorry. And then my slope, remember, rise over 1 for my parent function is going to be 1 over 1. All right, so that's how they got this black graph. So I go up 1 over 1, up 1 over 1, down 1 over 1. So that's my parent function, f of x equals x. Now, how I got to this blue function is now I have a minus 4, which means I go vertically down 4 from my parent function. So 1, 2, 3, 4. Everything else stayed the same. That's the only thing that changed is I vertically moved down. Okay, so that's just one transformation, a vertical transformation going down. Right? Perfect. And then how I would describe that, after you circle your transformations, you can go I'm just going to put VT for now, vertical transformation down 4. And that's how you should always annotate it on your tests and stuff. Right? So let's keep on looking at some more. Graphing and describing reflections. So for this one, it says graph P of X equals negative X squared in its parent function. Then describe the transformation. So our parent function for this one is actually going to be a parabola. So the parent function just looks like Y equals X squared. And again, we want to sit there and circle our transformations to see how many we have and really identify what they are. So let's circle what's different from my parent function and my function P of X. This negative right here being multiplied by my X squared is the only thing different from my parent function. All right. And when we have a negative that's being multiplied by my X, or my lead coefficient, or my lead variable, it's going to cause a flip, okay? And this one's going to cause a flip over the x-axis because it's being multiplied to the outside of my parentheses. If it was inside my parentheses, then we would be changing it. We would be flipping to y-axis. So our parent function, y equals x squared, that's just a parabola starting at the origin with a slope of 1. Okay, so that goes up. Now, all we have is that negative being multiplied by our x squared. So that's going to cause a flip over the x-axis, which we did. A flip over the x-axis, okay? That's what this negative caused. Right, and we're going to see some more examples of those later. All right, let's look at example 4, graphing and describing stretches and shrinks. So graph each function and its parent function, then describe the transformation. So for this one, we have for a, g of x equals 2 times the absolute value bars of x. So our parent function for this one is going to be y equals absolute value of x, and this causes a v shape, okay, which we call an absolute value function. And again, I'm going to circle my transformation. The only transformation I see is my absolute value bars are being multiplied by this 2. So remember in the beginning with our vocab, we said a factor of more than 2, or I'm sorry, if we say a factor of more than 1, then that means it's going to cause a stretch. So it's almost like we're pulling up our graph and it's getting skinnier, right? So with this one right here, we see our parent function is in black. That's just f of x equals absolute value of x. When we sit there and multiply our grouping symbols by that 2, and 2 is more than 1, that's going to cause a stretch, like it's getting skinnier. And that's what that 2 causes, or that stretches, okay, a vertical stretch. Now for B, we have y equals x squared. Our parent function for y equals x squared is our parabola. And remember that parabola starts at the origin. But for this one, we have it being multiplied instead of by a whole number, it's multiplied by 1/2. Now 1/2 is more than 0, but it's less than 1. So whenever we're sitting there multiplying by a number that's less than 1, but more than 0, that means we're going to have a vertical compression. And just think like you're pushing down on your graph and it's getting fatter or wider, right? So that's what that causes. Okay, let's look at one more example. This one, describe combinations of transformations using a graphing calculator. We're not going to use a graphing calculator. I'll explain how they got this one. G of x equals negative absolute value x plus 5 and absolute value minus 3 in its parent function. Then describe the transformations. So again, this is going to be absolute value. So let's always write down our parent function. The absolute value parent function is going to be y equals absolute value of x. And now I want to sit there and circle everything that looks different from my parent function. So this negative right here, this plus 5, and this minus 3. So that means I'm going to have 3 total transformations, okay? I like to jot it down so I don't forget how many I have, and I make sure I get them all. And let's move from left to right, naming the transformations. So this negative is being multiplied by my grouping symbols, or my absolute values. So I know that's going to be a flip or reflection. I'll put reflect. Reflect. I'll just put reflect. Yeah. Reflect over x-axis. Sorry, it takes me a long time to write with this pen. Over x-axis. And then the other transformation. Now notice the other transformation, that +5, is going to be within my grouping symbols. Whenever I'm inside of my grouping symbols, I'm going to sit there and deal horizontally. Okay, so this is going to be a horizontal shift or transformation. You can say shift or transformation, doesn't matter. I'll put horizontal shift. And whenever we're inside our grouping symbols too, we think opposite, okay? Because in this formula, there's usually a minus. And that minus is part of our formula, and we'll look up the whole formula of an absolute value function later. But we think of it like that, okay? And that's how that plus is formed. So this is a -5 going in for that transformation, okay? So this is a horizontal shift left. And if you can't remember that that negative is always there in that formula, just think whenever you're inside your grouping symbols, do the opposite, or the opposite direction. So vertical shift left by 5. All right. And now I'm outside of my grouping symbols, right? I'm not inside of my absolute value bars. That's what I mean by grouping symbols. So that means that when I'm outside of my grouping symbols, I'm going to sit there and deal with up and down, vertical, okay? It's going to deal with vertical shifts. Whenever I'm outside of my grouping symbols, I deal with vertical stuff, up and down stuff. And so we listen to the sign when we're outside of our grouping symbols. So vertical shift, down, 3. Okay. And then in that graph right there, right here, we can see our parent function. And this is where we're going to end up after we do all these transformations. So the first one was a flip. So it goes down over my x-axis. Then I shift 5 right. 1, 2, 3, 4. I'm not sure what this is scaled by, but 5 right or left. My apologies. And then we go down 3. Okay. And that would be my new vertex. And that's my new graph pointing down. -3. Okay. So we'll get more in depth with these in section 1.2. And if you have any questions on transformations or anything in Algebra 2, just sit there and write them in the comments. I can sit there and try to show you step by step how to get to certain homework answers or any questions that you have regarding Algebra 2. Thank you, guys.